What's up, guys? Welcome to this tutorial. Today we'll be looking at how to create a sign-in flow adhering to principles of clean architecture. I'll be using the layered architecture approach from the domain-driven design pattern. For this tutorial, I'll be using Node and Typescript, but the principles here can be applied using any programming language. But if you wish to follow along using the same programming language, then you can go to the GitHub repository in the description below and download the starter files. So let's begin. This repository. Okay, and I cd into the folder npm install to install the dependencies. Okay, open VS Code. Alright, so we have all our dependencies installed in the package.json file. Our TypeScript compiler setup. So now let us create some folders. I'll create a source folder holding our TypeScript source files. I'll create a dist folder for compiled JavaScript files and also a test folder for tests. Inside the source folder, we'll create 3 folders for now, in keeping with the layered architecture approach from domain-driven design. Those 3 folders are your domain, which is where all your domain objects are located. And this layer normally contains objects independent of frameworks and other libraries. We have just plain TypeScript objects here. We'll also create our application layer. And this is where all the coordination in the application happens. Here you'll have your use cases, your repositories, interfaces, and so on. And then we'll have our infrastructure layer. And this acts as a supporting library for all other layers, and it contains implementation for persisting your entities from your domain layer to the database, and you'll have other framework specific implementation details that are used throughout the system here in the infrastructure layer. So since we are creating a sign-in flow, we'll go into the domain layer and we'll create a user entity, a user object. As user constructor. We want an ID. String. We want name, email, password, now this type field is from the client side, if we are accepting authentication from OAuth services like Google or Facebook, so we'll accept the name of the person, the profile name, and also the type, which is whether it's Google or Facebook. These should be public. Okay, so that's our user entity, our user object. Now we'll go to the application layer, and there we'll have our use case. This use case for now is the sign-in action, because that's the action that the user will take. So I'll create an interface, I sign in use case, class, well, not really a class, an interface, I sign in use case, and this interface will have one method, which is to sign in. This sign in will return a promise of type user. Well, not user, because we do not want to expose user to whomever will be implementing or constructing this interface or using the use case. So instead of returning a user, which is a domain entity that we do not want to expose to the outside world, it's best if we return what is oftentimes referred to a response model, but in this case I'll use a DTO, or data transform object. So I'll return a user DTO. And I'll also accept a user DTO. So this user DTO is responsible for accepting the user input from the request body, transform that user input into the correct entity, which would be a user entity. And so it's basically transforming from entity to DTO and from DTO to the user entity. So let us create that user DTO. .ts interface. It will contain basically the same information as the user. So we have an ID, an email, name, password, and the type. So that's our user DTO. And we need to export this so that it will be accessible as a module. So here let us import our user DTO. We have our sign-in interface and our user DTO. So now let's create our use case. So our sign-in use case, which will implement or I sign. Need to export this interface and import it here. Public async. So our sign-in use case will accept an infrastructure, in this case a user repository, which that user repository is responsible for orchestrating the database call to fetch the user to determine if the user exists or not. So we'll have a user repository of type iUser repository. Let's make this repository a read-only repository, because its only function is to fetch the user. User read only repository. iUser read only repository. And inside our constructor, we'll say use this repository doesn't exist, so let us create this interface, So we have our use case inside our application layer. We also have our repository interfaces. Now we'll create our iUser repository. Export default interface. iUser repository, which has one method, which is to fetch the user. Returns a promise of type user. We need to export our user class. And import it here. If you are wondering where this @pbb came from in the path, this is something that we set up in the tsconfig file known as path aliasing right here. So you set up your path, you give it an alias, and you map the path. So this source path will be mapped to this alias. And then inside packages.json, there's a dependency known as module alias. And we use module alias to register the path alias. So this dependency, along with the tsconfig path alias, we now can use this alias for path instead of the ... for the relative path. So we fetch a user. Okay, so in our, let us import this now. So inside our signin method rather, let us create a user from our DTO. So new user from our data transform object. So also import user ID, then we have name, then we have email, password, type. So that's our user. That's our user. So we create our user, call fetch from our repository, fetch, pass the user, expected 0 arguments but 1. Fetch the user, then we create our user DTO. So this is our user DTO to return the result now, the user that we fetch to the caller. And we return that new user detail. Let's see. Found user. So that's our sign-in use case or sign-in method. We have our application, we have our now for our infrastructure. So now we'll implement our user repository inside of our infrastructure. But for now, I'm just gonna use a fake repository. This is where we would create a user repository that accesses the data layer to fetch a user from the database. And this is the beauty about clean architecture, is that you can differ certain implementation details. You do not have to decide upfront what kind of database you will use, that sort of thing. You can actually write your application using fake database, fake repositories, and be able to test your application long before you decide on which database you will actually go with. So for now, I'm just going to use a fake user repository. And this fake user repository will implement our iUser read-only repository. Or I can just create a user repository without implementing the methods. For now, implements import we'll have user so we'll leave it our user repository at that for now. User repository. So we'll now set up our entry point into our application. So I normally create a folder that I call entry point. And in that, I have controllers. I'll create a auth controller, export default, auth controller. Now, to create this controller, this is where I'll be using an npm package or library known as Inversify. Inversify basically is an IOC container that deals with dependency injection. So I'll use Inversify to create this auth controller. So I'll basically set up my routes here and also inject services in this controller. In this case, my iSignin use case, so that this controller can use it to execute the sign-in function whenever somebody visits the sign-in route. implements interfaces dot controller not Mocha. So I'll import from Inversify. I'll import controller, HTTP posts, interfaces, request, response from Inversify utils. I'll set up the base route. I'll add a dependency on our signing use case. So the thing about clean architecture is that the dependency is always inverted, so that the outer core depends on the inner core, and then the inner core is clean of all dependencies. I sign in use case constructor. So here in the constructor, I'll use Inversify to inject the iSignin use case. But because the iSignin use case is a part of our domain model in the application layer, I want to keep it independent of any framework specific detail. And so in using Inversify, in order to inject the signing use case directly in the constructor, I would have to annotate the signing use case with an @inject annotation, which I do not want to do because I want to keep all framework related details outside of my domain model. And so what I think is best here is to create another class that basically initialize the iSignin use case, and then we'll inject that class into the controller. So I'll create another class and call it auth service locator. Let me create service locator, and I'll call this folder configuration. Use cases. I'll create the auth service locator .ts. Create a public method that will get the sign in. use case, and this will return a new instance. Of the sign-in use case here. So to make this class injectable, using Inversify annotation, at injectable annotation, then inside this class I'll also inject our repository, because the use case, the sign-in use case, uses the user read-only repository. So I'll inject, but before I can inject, I'll go to and make this injectable. Inject a user read-only repository. Then we'll inject the read repository into our sign-in use case. Now we'll create the Inversify types. I'll create another folder, constants, and I'll create the types. So now we have our types that will be injected, and this is by Inversify. So in our service locator, let us import types. Now in our controller, let us inject the service locator. So we are going to inject types service locator. Then sign in. So this sign use case equal the service locator that get sign in use case. Now we can configure our sign in route using Inversify's at HTTP post annotation. Here we have the path, sign in. Public async sign in. Request express dot request now response let us import express. So now that we have our route and not the function that will be called, let us create our user DTO, our data transform object, from the request. Request.body. Import express. Right. So I'll return this sign in use case dot sign in, passing the user DTO. Then, since this is a promise, we'll subscribe. We'll also catch the error if there's any. So if there's an error, then our response.status, we set it to 400, and our JSON to error and the error message. If it is successful, then we'll return the user. So if it is successful, we'll have a user DTO. We'll set our result status 200 and our JSON body to the user. To the found user. So that's our entry point. Now we'll go back to the root. And now we'll wire up our application, our server, in the index.txt file. Because we're using Inversify, we have to first import reflect metadata, and this should be at the top of your imports. So import reflect metadata. Now we create our Inversify container. We create our Inversify container. Then we set up our bindings. This is for dependency injection. So container.bind or auth service locator. We're gonna bind our auth service locator. That's the class. Two. We're gonna do the same thing for our repository. So wherever Inversify encounters an iUser read-only repository, it will create an instance of user repository. Create our server. Inversify Inversify Express server. And we pass it to our container. We pass it to our container, then we configure our server, set config, pass in our Express application, just import Express, and inside our config we'll set up our application middleware. In this case I'll be using body parser as a middleware. Just import body parser. Use body parser.json. And we build our app. And we'll start our server. Listen. I'll give it a default port of 5000 for now. And we log to the console that the server has started. So there we have wired up our application. Now to test it, we'll be writing unit test using Mocha Chai instead of testing it using Postman. So let us write some tests. Into our test folder, we'll create one for controllers. And then in this case, we are testing the auth controller. So we'll import Mocha. We'll import I will describe our test. Which is our auth controller. So our system on the test will be our auth controller. So that's our system on the test. Set up our sandbox. Simons. We'll create a mock user, mock request, and a mock response. We'll create service locator, type auth service locator. We'll also use a fake repository with some preset users. Repository. So inside our test class, we'll create some helpers. And inside the helpers folder, we'll create a fake repository. We'll create a fake repository. So that's our fake repository. We'll also create our mock request and our mock response. Test. So inside our test now, we'll now create our request. Mock requests. Let's import mock requests, mock response from helpers. Put our fake repository as well. Again, for Inversify dependency injection to work, we have to import reflect metadata. So we have a mock request and we have a mock response. Now before each test, we want to create, instantiate a fake user repository. Our service locator. Passing our fake repository. Then create sign-on sandbox. Sign-on that creates sandbox. And our system under test, which is auth controller, we inject our service locator. Then after each test, we restore the sandbox. Okay. So let us write our first test. Sign in. So first test, it should return 400 on empty requests. So what we're gonna do is to spy using signup to spy on the response status method. And we want to spy on the response JSON method. Create an empty request. Then I'll call sign in, passing in the request, the empty request, and the mock response. This should be async. And then I expect the response status to have been called with with 400. Okay, so if we should run this test, no. Let us see. We should run this test using npm run test all. Test field. No test files found. Okay guys, so the error that we've got is that no test files found, and the issue is that it's looking for an underscore tests folder with an S, but here we have underscore test, so we rename this to tests and then we'll run it again. Run npm run tests all. So we have a failing test because the assertion is wrong. So we're looking for 400, but we got back 200. And the reason for that is that in our use case, we didn't check whether or not the user is found. We always return a user object. So we have to check if the user is found. So if the user was not found, then we throw an error. And if we run the test again, then it should pass. We should get a 400. Test field. Oh, I didn't save it. Run again. Now the test is passing. So we got a 400 whenever an empty request is sent. Okay. Let us move on to another test. So the next test now is that we should return a 200 and a user. So instead of sending in an empty request, we're going to send in the mock request. So now it should have been called with 200. And we expect the response.json method to have been called with the user, or the same user object that we passed in. User. Okay. Okay, let us run the test. Let's run it again. So the test failed. So we have an error right here. We try it again. It should have been called with 200. So the test passed. So the user was found in the fake repository. If you look in the fake repository, here's that user. So the user was found. So the user was found. So guys, that's it. You can write some more tests if you wish, but that's the approach to creating a sign-in flow, a clean sign-in flow using architectural patterns. This is quite simple. It's easy to add a sign up flow if you so desire, to add a sign up use case following the same ideas here. So I hope you guys learned something, and if there's any questions you can ask that down in the comments below. So I'll see you guys in the next one.